Hi, my name is Nick, and I would like to teach you how to build electronics. In this video, we'll be using the Raspberry Pi Pico H and a breadboard with some wire and wire strippers to build an LED that turns on when the board has power. I've built this new recording studio so I could have many videos on how to do projects like this, so please give me a comment at the end of the video to let me know what you think of the setup. In this video today, I'm going to use this Raspberry Pi Pico H breakout board for the RP2040 microcontroller. This is a nice board to play with because it's around $5 and you can program it in CircuitPython and C, but it has a few problems. One is that the labels for the board are on the bottom. So if you buy this version where the header pins are pre-soldered, none of the pins are labeled. So we're going to have to look up a picture of this board to figure out what pins do what. And there's no power indicator LED, so when you plug it into the USB cable, you can't tell if it's on. So the first thing I'm going to do is plug it into my breadboard, and I make some wires to put the power in the breadboard, and then I'm going to wire up an LED as a power indicator. So let's start with that picture. Here is the Raspberry Pi Pico H pinout, and we can see that there are power pins in the top right. So the third pin down from the top on the right is a ground pin, and the fifth pin down from the top right is 3V3 out. So that's the pin that supplies 3.3 volts to the rest of the board. Most of the circuits that we will be building will use 3.3 volts as a power, so I need to take that row when the board is plugged into the breadboard and turn it into many more holes. So here's a standard solderless breadboard. Underneath the holes in this white plastic are wires, so that when we plug a wire into a row, we can make many connections to that wire. The voltage along that wire will always be the same voltage. I've removed the backing of this breadboard so we can see those electrical connections. 5 holes in a row in the middle of the board are connected by one wire. Then there's a break or a gutter in the middle of the board, and then the row continues with a different piece of wire. So the left side of the board is not connected to the right side of the board. The edges of the board are columns of wires that we'll call rails. So the idea is we'll plug the Pico into the middle section of the board, and every pin on the Pico will have a row associated with it. And then we will take the power pins and put them into the rails so that we'll have power up and down the rails of the breadboard. Now, when you take your Pico, you have to plug it into the board. I wouldn't recommend putting it in the middle like this because you have to plug the USB cable in. And if you plug it into the middle here, you might not be able to get that cable in. So put it right up at the top and make it symmetric. Leave 2 holes on either side. And it takes a little bit of force because you have to plug this board all the way in. The black plastic has to be flush to the top surface of the board. So push it all the way in. Now we can come back to our picture, and we can see that the top right pin says V-bus. That's 5 volts coming from the USB cable. But most circuits don't run on 5 volts anymore, they run on 3.3. So what we want to do is we want to find that 3.3 volt pin, labeled 3V3 out, and the ground pin, and put them into the rails of the breadboard. To do that, we need to use some wire. So I've got a bundle of solid core 24 gauge wire and a pair of wire strippers. I like to make my own wires so that I can color code each wire specific to the function that it's going to use, and I can make it just the right length so it can be flush with the board. You can buy pre-made and stripped wires, but then they don't color code very well, or you could buy wires that have very nice hard end tips, but they will stick out from the top of your board and snag things and fall out. So the best thing you could do is just make your own wires when you need them. So let's make a ground wire first. So I'm going to untangle my bundle of wire. I'm going to squeeze my wire strippers a little and undo this little thumb lock to open them up. And this area down here is the cutter, and then these alligator teeth are for stripping the insulation off, and then we have a pair of pliers at the end. We're going to use black wire for ground, so I'm going to take some black wire, and I'm going to cut it initially to maybe 2 inches long. That's longer than I need, but just for demonstration purposes, we'll start long. And then I need to remove the insulation so that when the wire gets plugged into the breadboard, it almost bottoms out, leaving no exposed bare wire. So I'm going to remove about 5 millimeters of insulation from the wire. So I'll clamp down in the 24 gauge hole, and I should be able to just kind of tug that insulation right off. So sometimes you get a pair of wire strippers that aren't precision ground, so the hole that you're using might be a little too big or too small. So if I try to, I'll take another piece of wire here. If I try to take off the insulation using the 22 hole, it's really hard to pull off because the cutter isn't cutting all the way through that insulation. If I use the really smallest hole, the 30 gauge hole, I cut down and now I can't pull it off either because the cutter has cut through the insulation, but then it cut into the metal. And that makes a weak spot in that wire. So we don't want to use that. We want to find the right size hole for the wire that we have. So for this 24 gauge wire, I suspect the 24 or the 26 gauge hole is the appropriate size. So I'll do that to either side of my black wire. And then we'll find that ground pin. So the ground pins on the Pico, and there are several ground pins. We don't have to use the one on the top right, but that's the one I like to use. You also notice that they're pads are more square, whereas all the other pins are round. So it's the third one down, and I'll put the other side in the column that has the minus sign. So these plus and minus signs, that doesn't mean you have to use plus and minus there, but it would certainly be helpful to remind yourself later what you did. So I put the ground in the minus rail. So now this whole column next to the blue line is grounded. And ideally, I would have made that wire shorter so it was flush. Now when I put this in my book bag or something, it might snag and fall out. So in the future, I'll try to make my wires a little shorter, less loopy like that. So the fifth hole down from the top right is the 3.3 volt output pin. So I'm going to make another wire that's red. We'll try to use the convention that black wires are ground and red wires are power. And then in my wire bundle, I've got 5 other colors of wire, and I could use those colors for other types of signals. So the fifth pin down is 3V3 out, and I'll put that into the red plus column of the breadboard. So now, instead of having just 2 ground connections and 2 power connections, I've got lots and lots of power and ground connections coming from this side of the breadboard. But note that the breadboard is really 3 pieces of plastic. So this connection doesn't make anything in here, doesn't connect over here. So I'd also like to have power and ground on these rails, in addition to getting it from up here. So I'm going to take the power rails from here and jump them over to here so that I've got power and ground on both sides. So we'll take another black wire, kind of size it out by looking like that big, chop it off, remove the insulation on either side. Plug it in. So now we've got twice as many ground connections. Ground coming from the board into this blue rail, jumping over. Now all of these holes next to the blue column on this breadboard side are grounded. We'll do it one more time. Get a rough size. Cut the wire. Remove the insulation from either side. Plug into the breadboard. Okay, and then notice that I don't have any exposed wire, barely any exposed wire when these wires plug in. That way, a wire can't fall in here and touch across the power on the ground. That would create a short circuit. And notice that I did this construction while the breadboard was not plugged in to my computer, so I couldn't accidentally short my computer. So now if I do plug the USB cable into my board, we're going to be supplying 5 volts to the voltage regulator in the Raspberry Pi Pico, and it was programmed to blink a green LED that is pre-soldered to this board. But notice that there's no power indication LED. I don't have an LED that's just always on when I have power. So the last thing we're going to do is going to add an LED circuit just between power and ground so that we can figure out is the power on and available. So here's my circuit diagram from 3.3 volts. We're going to use a 333 ohm resistor in series with a red LED going to ground. LEDs are directional, so note that there's a long end and a short end to an LED. Here's a green LED. There's a long end and a short end. The long end has to be the more positive end because current flows from more positive to less positive voltage, so current is going to flow down in this direction, has to flow through the diode in the correct direction. If you plug it in the wrong way, the LED will not turn on. And the manufacturer is telling us which way is the more positive side by making one end long and one end short. when you look at the resistor, they are symmetric. It doesn't matter which way they plug in. So here's the thing about this circuit. I could build it a million different ways. We've got access to power and ground on either side of the breadboard. So I could build it over here, could build it down here, could build it across the breadboard. The circuit diagram has to match, but the physical locations of the holes that I use don't really matter. So let's start over here. I'm going to take from this piece of paper a 330 ohm resistor. This is a 5% resistor, so there are 4 color bands, orange, orange, brown, gold, and we could interpret those colors as a 330 ohm resistor. And I'll take a red LED. And so I'm going to start at 3.3 volts. So this column with the red line has 3.3 volts in it. And I'm going to put the other leg of the resistor in some random row. That other random row corresponds to where the resistor is going to be touching the LED. And then the long end of that LED has to be in that same row. And the second leg of the LED is in some other row. And so now I have to ground to that other row. So I need to make a wire to connect the short end of the LED to ground. So I'll grab some black wire, strip either end. Bend it around, plug it in. And as soon as that connection is made, the LED should turn on. Okay, I could have made this wire just a little longer. Okay, there we go. So we can see a lit red LED. Of course, I could have bent the legs of this LED to make it stretch further away, and then I wouldn't have had to add a black wire. So I could build this circuit with no additional wire, or I could have it go across the breadboard, because I could start at 3.3 volts, go to resistor, go to LED, and go to ground. And it doesn't matter where the ground is that I'm connected to, as long as I'm connected to some ground. So for this particular project that I'm about to do, I want to know when my USB cable is plugged into the Pico. So I want this red LED to always be on in that case. And I'm going to build it on this side of the breadboard, a little bit out of the way from the rest of the circuits that I'll use. This way, if this LED does not turn on when I plug the USB cable into my Pico, if that LED does not turn on, I'll know that somewhere else in the board I'm shorting, or maybe this wire has fallen out, or this wire has fallen out. But the fact that this doesn't turn on means that somewhere in the breadboard a wire has broken, and that will help me catch bugs that if maybe this wire falls out, a circuit plugged in here would work, but a circuit over here wouldn't work. So this red LED is really telling me the worst possible failure mode for this board. So I hope you like this type of video. This is a new setup for me, so down below in the comment section, why don't you give me a comment? Do you like the audio quality? Do you like the video quality? Do you like looking at this top-down perspective? Do you have a video that you want to see? Let me know.